Welcome to the DIY Honda Garage channel. The DTC P16 pertains to the starter cut relay 2 control circuit, high voltage, detected in the Honda CR-V 2023 and later models. This particular code indicates that the engine's Powertrain Control Module, PCM, has identified an abnormal high voltage on the return signal from starter cut relay 2 when the starter is engaged. The starter cut relay serves a vital role in controlling the ignition timing and preventing accidental engine starts. Its primary function is to interrupt or allow the flow of electricity to the starter motor based on signals from the PCM. If the relay detects a high voltage when it shouldn't, the PCM stores this DTC to alert technicians for further diagnosis. Components involved in this issue include the relay circuit board, the PCM, and various external circuits that connect these elements within the vehicle. Accurate diagnostic interpretation is critical to ensure proper repairs and restoration of vehicle functionality. The starter cut relay 2 is crucial in managing the conditions under which the vehicle's starter motor can engage. Located on the relay circuit board, this relay interacts closely with the PCM, or Powertrain Control Module. The PCM continuously monitors various signals and parameters, including voltages from this relay, to ensure that vehicle operations remain within specified limits. When the starter engages, the PCM expects a certain voltage return signal. However, if this signal is perceived as high, it triggers the error code P16F6. Understanding this relationship is essential, as it impacts both the engine's startup reliability and the overall operational integrity of the vehicle. Accurate identification of the relay's location helps streamline the troubleshooting process, allowing for timely corrective measures. Several possible causes can lead to the setting of DTC P16F6. One frequent issue is a shorted wire within the circuit related to the starter cut relay 2, which can cause incorrect voltage readings and confuse the PCM. An issue within the relay circuit board itself may lead to malfunctions in relay operation, resulting in abnormal voltage levels. Additionally, problems concerning the PCM can also contribute to this DTC. If the PCM is not functioning correctly, it may misinterpret regular voltage fluctuations as high voltage, triggering the error code. Each of these scenarios must be investigated thoroughly to pinpoint the exact cause of the DTC, as proper diagnosis is key in restoring system normalcy. When DTC P16F6 is present, several symptoms may arise that indicate a malfunction in the starting system. One of the most apparent symptoms is the vehicle's inability to start the engine, suggesting an electronic conflict at the relay level. Drivers may notice warning lights on the dashboard illuminating, signaling a fault detected by the PCM. Additional starting issues may manifest, causing inconsistent starter operation. While these symptoms may seem straightforward, the underlying electrical relationship between the starter, relay, and PCM could complicate the diagnosis. Observations of these symptoms should prompt an immediate troubleshooting process to avoid further complications. The first troubleshooting step involves starting the engine to confirm operational conditions. This initial action allows technicians to verify if the error code persists during normal vehicle operation. It is imperative to ensure that the vehicle is in the correct state for further diagnostics. Additionally, some fundamental electrical checks should be performed at this stage to ascertain the health of the starter system. Observing any behaviors or noises during engine start can offer insight into the condition of associated circuits. If the engine does not start or any irregularities occur, it may validate the presence of DTC P16F6. In the second step of troubleshooting DTC P16F6, The focus shifts towards inspecting the relay circuit board, which includes the starter cut relay 2. It is crucial to execute tests on the specified circuits, especially checking for a voltage short condition. This process involves ensuring that the relay functions within its designed parameters and does not exhibit signs of damage or wear. When performing the relay test, technicians must check continuity and monitor the behavior of the relay under varying conditions. If the relay tests reveal abnormalities, this component may require replacement or further analysis for underlying issues. Thorough inspection of this area aids in determining if this is where the fault lies. The next step involves checking the external circuit associated with the starter cut relay 2, specifically examining for any shorted wires. Electrical troubleshooting at this stage focuses on the wiring integrity connecting the relay to the PCM. Technicians should conduct a visual inspection, looking for signs of frayed or damaged wiring that could introduce erroneous voltage levels. Additionally, with the use of a multimeter, various points in the circuit can be tested for continuity and voltage specifications. Identifying shorts in the wiring can take significant time, but is crucial to finding the root cause of the high voltage error. Ensuring that the wiring adheres to Honda specifications is essential for remedial actions. If prior inspections have ruled out the relay and external circuits, the next logical step is to inspect the PCM itself. This module plays a pivotal role in interpreting voltage signals and managing relay functions, so any faults here could lead to erroneous DTC triggers. The PCM inspection involves ensuring that all connections are secure and free of corrosion. Diagnostics may require specialized equipment to confirm the PCM's functionality, such as the Honda Diagnostic System, HDS. If the PCM displays abnormal behaviors or errors in the diagnostics, replacement or reprogramming may be warranted. A functional PCM is critical for system health, and any issues here signify a deeper concern needing resolution. After completing necessary repairs for DTC P16F6, it is essential to perform a final repair verification step. This process involves using diagnostic tools to clear the DTC from the vehicle's PCM. Following the clearance, technicians should conduct a road test to ensure that the vehicle operates correctly and turn on no further warning lights. Testing the vehicle under different conditions helps confirm the integrity of the repair, ensure all previously identified symptoms have resolved. Validation of the repair ensures that the issues felt have genuinely been addressed, allowing the vehicle to operate reliably once more. Documenting this phase can also serve as a reference for future service. Preventive maintenance is vital in preempting issues that could lead to DTC P16F6 in the future. Regular inspections of electrical circuits connected to the relay circuit board can help detect signs of wear and tear or corrosion. Maintaining clean electrical connections is also crucial, as oxidized terminals can lead to voltage inconsistencies. Technicians should encourage vehicle owners to stay up to date with scheduled inspections and address minor issues before they escalate. Keeping an ongoing record of repairs and checkups fosters better overall vehicle health. Simple preventive measures can prolong the lifespan and reliability of key components, like the starter cut relay 2. In summary, diagnosing and resolving DTC P16F6 requires a systematic approach to identify the root of the problem accurately. The troubleshooting steps outlined guide technicians through inspections of the starter cut relay 2, the relay circuit board, and the PCM. Understanding the interplay between these components is crucial for pinpointing failures. After repairs, performing a final verification ensures that everything operates seamlessly. Additionally, implementing preventive maintenance is paramount to avoid potential issues in the future. A well-maintained vehicle not only enhances reliability, but also ensures safety on the road, showcasing the importance of robust diagnostic practices and routine care. Please like and subscribe to the channel. See you next time!